Hi everybody, today we're going to talk about solving trig equations that are either quadratic in form or use trig formulas in order to solve. Let's start with solving the equation over the interval 0 to 2 pi, given 8 sine of 2 theta minus 6 sine theta equals 0. We're going to write our answers rounded to at least 2 decimal places, or we can write them as exact answers when appropriate. What I want you to notice in this equation is the sine of 2 theta. We want to rewrite sine of 2 theta using our double angle formula. Instead of having 8 sine of 2 theta, I want to have 8 times 2 sine theta cosine theta. We keep our minus 6 sine theta, and we set it equal to 0. We can quickly multiply 8 times 2 to get 16 sine theta cosine theta minus 6 sine theta. Our approach to solving will be the same kind of approach we have when we do algebra. We look at our terms and we see what do they have in common. I can see both terms have a sine theta, and both terms are even. I'm going to factor out a 2 from the 16 and 6, and I'm going to factor out a sine theta from both terms. 2 goes into 16 8 times. The sine theta has been factored out, so now I have a cosine theta. 2 goes into 6 3 times, and the sine theta has already been removed. On the right side, I still have this is equal to 0. Now that my equation is in factored form, I can use the zero factor property to set each of the terms equal to 0. I have 2 sine theta equals 0. I have 8 cosine of theta minus 3 equals 0. 2 sine theta being equal to 0 says that sine theta is 0. 8 cosine theta minus 3 being equal to 0 says 8 cosine of theta equals 3, and that cosine of theta equals 3 over 8. Let's deal with the sine theta equal to 0 first. We know from using our unit circle that sine theta is equal to 0 at 0 and also at pi. So there's two solutions to start. Theta is 0, theta is pi. When cosine of theta is equal to 3 over 8, we want to find the cosine inverse of 3 over 8 to find our value of theta. Before we start, I want to think about where theta could be. Theta can be in quadrant 1. Theta could also be in quadrant 4. So again, I expect two solutions to this equation. So in my calculator, I'm going to first switch to radians. Then I'm going to find the cosine inverse of 3 divided by 8. And it tells me 1.186. 1.186 is in quadrant 1. To find my second value, I'm going to subtract 1.186 from 2 pi. This gives me a value of 5.097. Our four solutions over the interval from 0 to 2 pi will be 0, pi, 1.186, and 5.097. Our next problem says solve the equation over the interval 0 to 2 pi, given 2 cosine squared theta plus cosine theta equals 0. When I look at this problem, I notice that everything is a cosine. When I factor out cosine theta, I have cosine theta times 2 cosine theta plus 1 equals 0. We'll set cosine theta equal to 0. I'll set 2 cosine theta plus 1 equals 0. I need to move the 1 to the right, so I have 2 cosine of theta equals negative 1. Dividing by 2, I have cosine of theta equals negative 1/2. Cosine of theta is equal to 0 at pi over 2 and 3 pi over 2. Cosine of theta is negative in both quadrants 2 and quadrant 3. This tells me I have two values of theta when I find the cosine inverse of negative 1/2. Cosine has a value of negative 1/2 at 2 pi over 3 and at 4 pi over 3. So once again, I have four solutions. I have pi over 2, I have 3 pi over 2, I have 2 pi over 3, and 4 pi over 3. My next problem says cosine of 2x equals 15 cosine x plus 7. Even though this problem only involves cosines, having the double angle says I need to do an expansion. If you remember back to double angles for cosine, you have three versions of what you can use. For this particular problem, I want to use the version of the double angle that only involves cosines because I have the 15 cosine x on the right. I'm going to write cosine of 2x as 2 cosine square root of x minus 1. And we'll keep that equal to 15 times the cosine of x plus 7. I'm going to bring everything to the left side. I have 2 cosine squared x minus 1 minus 15 cosine x minus 7 equals 0. This simplifies to 2 cosine squared x minus 15 cosine x minus 8 equals 0. 2 cosine squared x only factors to 2 cosine x times the cosine of x. What I need to look at is how is 8 going to deal with that? So I need to put in the value of 8 in a way that I'll come up with 15 as my middle term. If I put an 8 on the right side, 2 times 8 is 16, and then if I put a 1 in, 16 minus 1 will give me 15. We want to pay attention to the signs that we put in each of our factors. I want the 8 to be negative, that way I have negative 16, and then a plus 1, this gives me 0. I need to set each of these terms equal to 0. 2 cosine of x plus 1 equals 0 says 2 cosine of x is negative 1. Cosine of x is negative 1/2. My second term says cosine of x minus 8 equals 0, which simplifies to cosine of x equals 8. We can throw this out. We know that cosine will always be from negative 1 to 1, so 8 is outside the range of cosine, and I don't need to use it in my solution. The only thing I need to look at is the cosine of x equals negative 1/2. So we can find the cosine inverse of negative 1/2 to get our value of x. We just said cosine is negative in both quadrants 2 and in quadrant 3. Cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So this time we only have two values for x. Next we have 2 sine squared theta equals 3 minus cosine of negative theta. The first thing I notice is the left side is sine and the right side is cosine. I would like them all to be the same. The easiest thing to change will be sine squared theta. I can write sine squared theta as 1 minus cosine squared theta. I'm going to distribute the 3, so 3 times 1 is 3 minus 3 cosine of negative theta. I'm going to push through the 2. 2 times 1 is 2 minus 2 cosine squared theta equals 3 minus 3. Cosine is even. Cosine of negative theta is the same thing as cosine of theta, so I can drop the negative in front of the theta. I want to bring everything to the left side of the equation. I have 2 minus 2 cosine squared theta minus 3 plus 3 cosine theta. This now is equal to 0. I'm going to put the negative 2 cosine squared theta first. Then I'll put my plus 3 cosine theta. I combine the 2 with the negative 3, which gives me negative 1 equals 0. I like my leading coefficient to be positive, so I'm going to divide each of my terms by a negative 1. I get 2 cosine squared theta minus 3 cosine of theta plus 1 equals 0. Now I can factor. 2 cosine squared theta only factors to 2 cosine theta and cosine theta. 1 only factors to 1 and 1. The sign of both terms should be negative. When I set them equal to 0, I have 2 cosine theta minus 1 equals 0. I have cosine of theta minus 1 equals 0. The 2 cosine theta minus 1 equals 0 becomes 2 cosine of theta equals 1. Cosine of theta is 1/2. Cosine of theta minus 1 equals 0 says cosine of theta equals 1. Cosine of theta is positive in quadrant 1 and in quadrant 4. Cosine theta is 1/2 when theta is pi over 3 and 5 pi over 3. Cosine theta equals 1 only when theta is equal to 0. We have 3 solutions for theta. We have 0, pi over 3, and 5 pi over 3. Notice when I can put in exact answers, I do, but if I need to use my calculator to get the inverse, then I'll rely on decimals. Our last one says find all solutions to the equation. So I don't have a restricted domain, which means I need to include the general solution. For sine, that means we're going to bring in 2 pi k, where k is an integer. To start, we're going to factor. I have 2 sine squared theta plus 3 sine theta plus 1 equals 0. 2 sine squared theta factors to 2 sine theta with sine theta. And 1 factors into 1 and 1. This time they're both positive. We have 2 sine theta equals negative 1. We have sine theta equals negative 1. This says sine theta equals -1/2, and we keep the sine theta equals -1. Sine is negative in quadrants 3 and quadrants 4. For these cases, theta will be equal to 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. Sine theta is equal to -1 when theta is equal to 3 pi over 2. So our other solutions occur at 3 pi over 2 plus 2 pi k. It's important to remember to put the 2 pi k period in anytime we don't have a restricted domain to our equation.